Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. A ground truth in data science is you are always interested in knowing the population behavior, but you never work with a population. You always work with a set of observations from the populations, which is called sample, and you can calculate and observe the sample statistics. Like, for example, mean is a statistic, standard deviation is a statistic. You calculate those statistics, and with those statistics you estimate the population parameters. You can never calculate population parameters. Now, since you are only working with a small set from an infinite population, estimating population parameters by only calculating that sample statistics for that small sample is not enough, because you are probably calculate estimating the population parameter with very small degree of variance. You are not saying, you don't have a confidence level, or you don't have an interval for the population parameter. You just have one point, one possibility of the population parameter. So to increase the number of possibility, or to know the distribution of the population parameters, ideally what you would want is you would want to calculate the sample statistics on several different sets, random sets of sample, from that population. So let's say if you had 10 sample sets, 10 randomly selected sample sets, and you calculate sample statistics on those 10 sample sets, then you could have the population of you could have the distribution of population parameters from those 10 sample sets, and then you could say something about the population with more certainty than what you would have done with just one sample set. But do you have 10 sample sets? You don't. You only have one sample set, and with that sample set you need to be able to estimate the population parameters. How do you do that? This is where cross validation techniques come in. So simplest of cross validation is basically you have a sample set, you split the data of that sample set into two sets. One is your training set and one is your validation set. You train your model on the training set and then apply it to the validation set and see if it gives you the same result. The performance of your model on the validation set will always be identical or less than what it was on the training set. So think about it. What did you do just by splitting the data? You created a model that has some parameters about the population, but just that model on the training data is calculations on a sample set. You are saying nothing about the population. You're talking about one possibility, right? Just by adding a validation state, you started talking about the population, because now you have variation in your population parameter. You kind of simulated a situation where you have two sample sets, not just one sample set. And with that variation, you're mildly successful in saying, I can estimate the population parameter with just one unit of variance. But is that enough? No, it's not enough. You need to introduce more variance in your population parameters, since you need to be more sure about the interval of your population parameters. By only having one additional possibility for your population parameters is not going to suffice. So that means you don't only need one validation set, you need multiple of validation sets. Do you have them? You don't. You only have one validation set. So you better work with it. So that means we can't split the sample set only once, but we need to split it multiple times. And that's called k-fold cross validation. You split the sample set k times, and then you calculate the sample statistics on each set. And by doing this, what you are doing is you are adding variance to your estimated population parameters. but that's still just K sets, right? What can you do to have more uh, validation sets from the same sample set? So there is one other method of validation which is called LOOCV, or leave one out cross validation, which is basically you don't split the data into K. You basically take one sample, one data point out of your set, and then calculate the sample statistics on the sample minus one data set, and then you do it n times, do it for all the data points in your sample set, so you leave one out each time. There is a slight problem with this approach though. Suppose you are taking a training set and validation set from a population, you would choose two completely random sets and you would be good, right? You want them to be completely random sets. But the problem is when you're choosing them from your sample and not from your population, the selection of the training data set is not entirely random. When you choose a training set and you keep the other set for the validation, you are making one decision and other decision is already made. The events are not mutually exclusive. The data sets are not completely random. They are not independent. And what you want in ideal situation is randomly selected sample sets. So how do you solve this problem? You want to have as many random sets as possible from the population, but you only are working with one sample set. And with that sample set, now you want to simulate the possibility of randomly selecting sample sets with as much to add as much variance as possible to your population parameters. So you can solve this problem to a better, not ideal, but better degree of randomness by bootstrapping. And what bootstrapping does, it randomly selects observations from samples for a particular sample size. So if you have hundreds data points, and then you say my bootstrapping is going to be for 90 data points, it randomly is going to select 90 data points at one time. And once the sample is selected and you have the sample set, you put those samples back into the bin and you select the observations again. So there is a possibility of selecting one data point multiple times, or two data points being identical to each other, but it is still random. And this kind of mimics selecting random samples from the population and gives you an ability to choose as many data sets as you want. Isn't that cool? So all you are trying to do in data validation or cross validation is you are trying to simulate the possibility of selecting random sets from a population so that you can add more variance to the population parameters, and you are trying to get to a point where you can calculate, or you can have some distribution of distribution for population parameters, and you can estimate the population parameters with more certainty. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.